Welcome back to Inclusive Design 24 for our final session this year. It's brought to you in partnership with Barclays Access, the Paciello Group, Intopia, Microsoft Edge, and Open Access Technologies. So for the last time today, you can subscribe to Inclusive Design 24 on YouTube by hitting the subscribe button, and please follow us on ID24Conf on Twitter. If you have any questions for Aaron, who's coming up next, please tweet them using the ID24 hashtag, and we'll ask them at the end of the session. Adrian, do we have anyone else watching us?
We do. First, I'd like to say thank you for all of the meetup groups, official and unofficial, who have been watching throughout the day. We have had organized groups from India through Australia, through Europe, and across the Americas who've participated today, and that's awesome. And we are down to one group who is still participating. That's the Los Angeles Accessibility and Inclusive Design Meetup, located in Los Angeles. So thank you for joining. Feel free to ask questions using the hashtag, and we look forward to your participation. And next we have Aaron Gustafson, who's going to be talking about better performance equals greater accessibility. Off to you, Aaron.
Awesome. Thank you guys so much. So yeah, hi, my name is Aaron Gustafson, and just as a little bit of background, I am a former Web Standards Project person. I used to manage that organization back in the heady browser wars days and such. So I've been very involved in the web standards and accessibility world, and my current role is I'm a web standards progressive web app and accessibility advocate at Microsoft. Now, today I want to talk about accessibility in kind of a broad way and how performance affects people's ability to access our content on a very fundamental level. But before we tuck into the nitty-gritty, I want to give you a frame of reference for this talk. You'll see a bit of code and you'll hear some kind of technical words and acronyms, but ultimately this talk is about design. I love this quote from Jeff Bean. I've been amazed at how often those outside the discipline of design assume that what designers do is decoration, likely because so much bad design simply is decoration. Good design isn't. Good design is problem solving. In terms of designing user experiences, the problem we're often charged with solving is how to help users accomplish a task. In most cases, we want to do as much as we can to remove any obstacles that can get in their way. You know, friction. This is probably the 48th time that you've heard the word friction in a conference, and there's a reason for that. Our job is to reduce the friction in order to help people do what they need to do with as little pain or annoyance as possible. Now, I don't think many folks on the line or watching this later on would argue with me that some of the hallmarks of a good user experience are a streamlined flow, clear, concise copy, low cognitive load, and fast performance. Now, to share a little story, back in March of 2012, Apple announced the third generation iPad, which had their high resolution Retina display, right? I was staying at a hotel, oddly enough, in Silicon Valley, and I decided to head over to apple.com to check it out. It took me over 30 minutes to load the page for the iPad over the hotel's Wi-Fi. Now, that delay wasn't due to the server being overwhelmed. Even the hotel internet wasn't entirely to blame. The culprit was Apple sending every browser a high-resolution image, regardless of whether the user's device could even handle it and whether or not they even wanted it. This was in the days before we had responsive images with the picture element and source set and sizes, and so they sent the same image to absolutely every device, even small screens connecting over mobile pay-per-bit data plans. Now, we need to be concerned about the performance of our web pages because poor performance is friction. Now, I'm sure many of you have seen countless studies that have shown time and time again that people want speedy access to websites. It matters. The Harris poll found that speed was the second most important attribute of a website, ranked right behind easy navigation and just ahead of reliability. In other words, they would rather a website be fast than work all the time. Now, moving on to Akamai and Gomez data, Kissmetrics determined that a 1-second delay in page load can reduce conversions by about 7%. Translated to the real world, that means like for an online shop that earns about $100,000 a day, that's about 2.5 million in lost sales. So of course, this is all somewhat hypothetical, so let's look at some practical examples. Amazon knows how much poor performance costs. They've calculated that 1 second delay is worth about 1.6 billion to them in sales. And Mobiquity found that slow mobile load times was the greatest source of frustration for mobile shoppers. When they did their research back in 2014, they found that 42% of their respondents found slow mobile loading times to be the source of the greatest frustration for them. Google found that about 53% of people abandon websites that take more than 3 seconds to load. They've adjusted that stat over time. But shifting gears from negative to positive, Edmunds found that by shaving 7 seconds off of their load time, their page views went up by 17%, and their ad revenue increased by 3%. That's pretty significant. That's money in your pocket. And Mozilla found that reducing page load by 2.2 seconds actually gave them an increase in downloads of 15.4%, which is also pretty significant. So it should be obvious to most people who work on the web that performance really matters. And that's one of the reasons that we decided to revisit the 10K apart contest back in 2016. Now, if you're not familiar, in 2000, there was the 5K challenge, which was created by Stuart Butterfield, who later went on, or I guess actually earlier went on to found Flickr and later went on to found Slack. And what he did with the 5K challenge was challenge people to develop a web experience that could be delivered in 5 kilobytes or less. Now in 2010, an event apart and Microsoft kind of picked up the mantle and returned with the 10K apart challenge, which was gave you twice the amount of size overall, and was challenging basically you to do the same thing to create a great experience in 10K. And the next year, in 2011, it returned with a focus on building out responsive entries. Now, when we looked at bringing it back for an event apart's 10th anniversary, we felt that the setup was really skewing everyone towards building very JavaScript-heavy apps. And the reason for this was that the contest didn't support any sort of backend. Everything had to be submitted as a self-contained zip. So for interactivity, they had to basically rely on JavaScript. So for the 2016 edition, we decided to switch things up a bit. We were looking for usable pages to be delivered in 10K or less, that the pages be accessible via screen readers, the keyboard, and so on, that entries follow the philosophy of progressive enhancement, that users could do what they needed to do without JavaScript at all, and ultimately, all of these aspects were about trying to improve the user experience and, moreover, improve the performance of a given project. So in building the website to explain and provide rules and stuff like that for this contest, I decided to challenge the team making it to actually make the contest site abide by those very same rules. After all, if we were going to ask it of others, we really didn't want to be hypocrites, right? In other words, we decided to eat our own dog food. Now, before I get into kind of the ins and outs of some of the performance optimizations we made to the site, I want to give you a quick overview of how pages load, just so that everyone is on the same page. This isn't going to be exhaustive, but it will give you a sense of what we're dealing with when we deliver things on the web. Now, the first step when you enter an address in the URL bar or you follow a link is that your device does what's called a DNS lookup. So it would ask something like, where can I find akapart.com? And then somewhere on the web, or maybe cached locally in their network or in your provider's network, the DNS lookup would be resolved, and they would say, okay, you can find this domain name at this particular IP address. Then the browser and the server do a little greet of each other. We call it a handshake. It's the TCP handshake. So the browser reaches out, and the server responds, hey, I'm right over here. Then the browser requests a file. So I'd like the index file, for instance. And then the server does some form of processing on the server side. So it could be something as simple as finding a static file, or it could be retrieving a ton of data from a database and crunching a bunch of numbers. So this kind of part of what the server is doing is wildly variable and can totally be tuned for better performance as well. But the discussion of that kind of falls outside the boundaries of this talk. But eventually, the server has a response to return to the browser, and it goes ahead and does something and passes it back, rather. And then once the browser has the response, it can get to doing something with it. So the browser begins to do some work. Now, the rough process that a browser goes through from receipt of the response to actually having a fully loaded page is actually kind of a multi-step process. First, you have the response received. Then you have the DOM being constructed. Then you have the CSS being parsed and figured out. You have the render tree being generated, layout being figured out, and painting or composition, it's sometimes called. And then finally, you end up at this kind of loaded state. Now, one of the challenges here is that when we are using CSS and JavaScript, we can actually cause delays in rendering, or we could even cause these different steps to be run again, because CSS and JavaScript are both considered blocking resources. So I'm going to step into a very bare bones HTML document and kind of show you step by step how parsing happens generally. There are some micro optimizations that individual browsers make that are unique to them. And this is a somewhat contrived example, but I think it's helpful for informing us how all of this comes together. So you have a better sense of how markup and source order affects page load performance. So the DOM parser begins at the start of the document, as you would expect. So it hits the HTML element, the head element, the title. These are all just text things. And then there's a script element that it hits. And this is a script that exists in the head of the document, and it's got a source to an external file. So this causes the browser to wait while it fetches and parses that script, because it may do some sort of manipulation to the page. So it needs to figure out what that's going to do. Then it moves on, and there's a link element for an external style sheet. So the browser has to wait and fetch that and begin parsing the CSS. It then gets to an inline style block, but it can skip over that. It can skip over an inline script and just kind of keep on chugging through, exits the body, or exits the head, enters the body, hits an image, then gets down to the script element at the bottom of the body, and then it has to wait for the browser to fetch and parse that script, and then finally finishes moving out of the body and out of the HTML. So I didn't talk about fetching the image because most browsers kind of offload the fetching of an image to a separate process, and it doesn't really affect the overall rendering of the page. Now, with all of this in mind, here are my recommended first steps for performance tuning your projects. First of all, use native features whenever possible. Second of all, only include the assets that you actually need. Third, optimize everything. 4, think about when you load assets. 5th, consider how you load assets. And 6th, only load assets when they actually add value. So I'm going to take you through each of these individually. So step 1, using native features whenever possible. Why do we do this? Well, because they're effectively free. So for example, here we have a header element with just some content inside of it. Now, this is not only shorter than saying div with an ID of header, but it actually provides some semantic value for screen readers or for virtual assistants to take advantage of. There's other things, there's meaning there that could be exposed in some way to users if the user agent and such wants to actually do something with it. And depending on its location in the document, this could also provide a landmark for navigation within the page. Because if it's the first header element, and it's not contained in any sort of sectioning element, then it would actually be the banner role that it would inherit automatically. As another example, here we have an input, just a fairly normal text input, but using the required attribute, modern browsers will actually require users to enter content before the form will be submitted. Using ARIA required equals true can inform assistive technology that the field is required. Using autocorrect off will tell the browser not to try and correct someone's name, which this is a field for someone's name. using a placeholder gives us that auto disappearing suggestion without JavaScript. So in this case, it's asking for somebody's name. So Sir Tim Berners-Lee is in there. And then this last piece that I've got in there is the autocomplete attribute. And if the browser already knows the user's name, then the browser can actually pre-populate that because it knows what the name key is that's been fed into the browser. So it can populate that without the user having to do anything, really, which is pretty awesome. If you're interested in more about autocomplete and so these tokens, I highly recommend Jason Grigsby wrote a very exhaustive walkthrough of what autocomplete is and how it works on the Cloud4 blog. So that's definitely a great resource. Now here we have another input. This one is an email field, so it's requesting the person's email. And in this case, we've got the things that you expect in terms of required and such. But using a type of email, modern browsers will validate the email address, and they may supply a custom keyboard layout for somebody who is using a machine with a virtual keyboard, for instance. And here I'm also using the autocomplete equals email. So I'm using the email token in the autocomplete field. So if the browser knows an email address for this person, it could suggest it for them. Similarly, modern approaches for layout are far more code efficient. Doing your layouts in Grid or doing them in Flexbox, you can write a lot less code to achieve the same things that we have been spending a lot of code trying to do using floats and such. So these are so much better than using floats. And modern JavaScript can allow you to work without libraries. So in this example here, I'm actually doing CSS selector-based DOM traversal without relying on jQuery or any other JavaScript library. Instead, I'm using document.querySelectorAll, which does the same thing as the $ function in jQuery. And I'm able to put in there the string of input, and then in square brackets, type equals radio. So I'm selecting all inputs with a type of radio. I'd also recommend making use of system fonts as much as possible. You can create really elaborate font stacks offering a bunch of different options that should produce a desirable match. What I have up on the screen here, we had a serif font stack that was Georgia Times New Roman and serif, nothing terribly exciting there. For the sans serif stack, we had Segway UI, Frutiger Linotype, Deja Vu Sans, Helvetica Neue, Arial, and sans serif. And for those of you that can see the screen, the fallbacks, I've got the different fonts up here just to sort of show a comparison of how they end up being rendered in the browser. The fallbacks were relatively close, or at least close enough not to present really weird layout issues when our top picks weren't available on a particular device. If you decide that you do need a custom font, whether it's from an online font foundry or something like that, or it's one that you're going to upload to your own server, subsetting is a great way to go. And what subsetting means is it means you're removing unused characters from the font file. So if you've got a font file that has every UTF-8 character in the world in it, but you are only producing content that is in US English or something like that, there's a lot of characters that you don't need access to at all. And there are a bunch of tools that you can use for doing this. There's the command line, there's Font Squirrel, and then services like Typekit and Google Fonts also support doing subsetting in their systems too. But it's important that you be cautious in how you do this, because you might discover that you've removed a character that you've actually needed. So I have this example from Brandstein that's I heart München, or München. My German is horrible. But in this case, the U with an umlaut is actually being rendered in a different font because the custom font that is being used for the majority of the text is not available. And so it's falling back to a different font on the system, which looks vastly different. So you want to avoid doing that as much as possible. All right, step 2. Only include the assets that you actually need. So there are a lot of great tools out there, many, many more than you actually may need. and by this I'm talking about things like jQuery and Bootstrap and Meteor and pure CSS, Modernizer, all of these things out there. They can be great, but they might also be overkill for the project that you're working on. So just to give an example, every tool has a cost. So I've got a chart up here that shows the size comparisons of a bunch of different frameworks and JavaScript libraries and stuff like that. But just to kind of call out one example, if you use Foundation all up, that's about 266 kilobytes or a relatively large image worth of code, and you're likely to only be using a portion of it. Now, some of these libraries and frameworks do enable you to customize a build to your needs, only including what you're actually using, but very few people actually do that. And one story I like to share is a colleague of mine was hired to consult on the performance of a high-profile retail website. And when they were complaining because the site was really slow, and so he came in and he like popped the hood and saw that they were using jQuery and Prototype and Scriptaculous and MooTools and a handful of other libraries. And in total, they were actually loading about 3.5 megs of JavaScript, all because their developers didn't standardize on a single library, and they just added these willy-nilly as if they were free. Christian Heilman likes to refer to a certain type of developer as the Stack Overflow developer, somebody who just looks up what it is that's on Stack Overflow and is like, okay, here's the solution to it. Oh, and it requires this library. Okay, I'll just add that to the project. And so that had obviously happened in the case of this retail website, because nobody in their right mind who is actually thinking about performance would add all of these different libraries, which all do roughly the same thing. Now, some folks rely on a content delivery network or a CDN to deliver the libraries that they use, and that can be great as long as there's not a network issue. But what CDNs enable is, like, for instance, if everyone is loading jQuery from the jQuery CDN, once it's loaded from that URL, the browser can keep it around, and as you browse around the web, everybody that references that same one just gets it from your cache as opposed to having to download it. That's pretty awesome. But it's important to remember, as I mentioned before, that these CDNs can incur additional overhead in the network in order to connect to them. And that can cost precious time, especially on high latency mobile networks. For each CDN domain, we might have to go through the whole connection process to request a file. So that means the DNS lookup, the handshake, and then the actual request. And the more CDN shards or CDN servers that you're using, the more connection overhead you have. Now, we can optimize some of these steps a little bit. So if we wanted to look to optimize the DNS handshake, we can actually use what are called resource hints to do that. So this uses a link element. And this particular one, if we want to do the DNS lookup to find the server early, we can say link rel equals DNS-prefetch, and then the href value is the URL that you're pointing to. And so what that tells the browser to do is, like, hey, when you've got a spare moment, go ahead and kick off a DNS lookup for this. I'm going to need it. I'm going to need something from this server later. So you would drop this in the head of your documents. Now, you can actually optimize from the DNS lookup to the handshake as well. And so you can do that with the pre-connect one. So you would do link rel equals pre-connect, and then the href would point to the domain that you're going to. You can even optimize requests for specific files as well, which is pretty cool. So what you do is, again, using the link element, you have rel equals preload, and you provide the full path to the file that you want to request in the href attribute. And then you can indicate using the as attribute that, in this case, I'm requesting jQuery from some CDN. So I'm going to load that as a script. Now, this helps to further optimize the process because I'm telling the browser that the resource that I'm requesting should be considered to be part of the scripts stack of requests that they're making, so that they can kind of further optimize the loading process and kick off that task at the right time. Of course, download isn't everything we need to worry about. So this is a little dated now, but a few years ago, the Filament group ran a test, and they built the same app using several frameworks that were commonly employed at the time. And they tested how long it took for those apps to become usable. And they compared them in terms of whether it was a desktop PC being connected to a cable modem or over a 3G connection. And they also compared those against a Nexus 5, which was actually a pretty high-end Android device at the time, but also over a 3G connection. So Ember 1.9, which was the then current version of Ember, was actually the worst offender in this. And it took nearly 5 seconds for the page to become usable on a mobile device on a 3G network. Now, the reason for this was a combination of poor network performance, as we would expect, but also combining that with the slower mobile chipset. Because once you have the library downloaded, you still have to boot it up and then run everything through that library. And the reality is that library speeds, the speed of code that is written for a library, the speed of execution is always going to pale in comparison to that same task being done in vanilla JavaScript. And the reason for this is that every layer of abstraction that you create is going to reduce your performance. So as a quick example, doing an ID lookup using jQuery runs about 98% slower than the native DOM method. So the chart that I have up here shows a vanilla JS version of document.getElementById by ID versus Dojo, Prototype, EXTJS, jQuery, et cetera, et cetera. And you could actually perform over 12 million operations, so 12 million getElementByIds in a second, whereas jQuery can only do about 350,000. Okay, the next closest one was Dojo's by ID, which could do about almost 5.5 million. But it's still like that was half the speed, less than half the speed of the native JavaScript thing. So in building the 10K apart website, we opted to skip doing libraries and frameworks altogether and pretty much write everything from scratch. We did use some resource hints in order to pre-connect to our data store, which is how we were making database queries and stuff like that. And we did use Cloudflare for some CDN stuff, and we were doing Google Analytics, so we did some pre-connections to Google Analytics as well. We did borrow one small SVG support test from Modernizer, credited of course, but that was the only piece of code that was not entirely bespoke for this project. So step 3, optimize everything. So we used Gulp to help out with a lot of the optimization work, and Gulp is great, but it's not the only game in town for this sort of thing. There are other task runners like Grunt or even Make, and of course there are bundling systems like Webpack or Parcel, and I'm not here to tell you what you should use. You should figure out what's right for you and your team, but it's important to point out that this was really useful for us because it allowed us to pre-compress our access, which meant there was one less thing for the server to do. So the process of kind of architecting this out from a CSS standpoint was that we would write our CSS modularly using Sass, and we used a Sass plugin called Breakup to manage our media queries. We would then compile our Sass into CSS with a precision of 4 decimal places, and we used Gulp Sass in order to do that. We chose 4 decimal places because that gave us the greatest accuracy in terms of layout. We did not do this. This was pre-grid, so we didn't use grid for layout, so we were doing a lot of float stuff, which is why we did the decimal places. Again, less code with grid if you can go that way. We used fallbacks for the last 2 browser versions. We did that using Gulp's auto prefixer plugin. We made sure that we had kind of an additional pass through the CSS that was automated that looked for any chances that we could use CSS shorthand if possible. So if, for instance, an element nowhere else in the DOM was being touched by a background-related property, and we had written it out as background color, it could reduce it to just background and then apply the color value, for instance. So that would be a little bit shorter to send over the wire if you can do it. We then had a separate process. We used gulp shorthand for that, by the way. We had a separate process that would remove any unused declarations and rule sets, and it did that using gulp uncss. So that would keep us honest if we, I don't know, removed a component and forgot to take that out of the CSS. This would clean that up for us. We then optimized the files using gulp CSSO, and then minified them using gulp clean CSS. And then we gzipped them. We went ahead and did that gzipping during the build process rather than having the server do it dynamically. And we actually did Brotli compression as well. And then all the server had to do was decide which compressed version to serve. So if the browser could support Brotli, it would get Brotli. If it could support gzip, it would get gzip. Otherwise, if it couldn't support any of those, it would just get the minified CSS. So if you were to look at the repository for all of this stuff, there were just a bunch of CSS files in there. But once these various gulp processes, once this CSS rendering task was run, you would have a resulting folder with a couple of different versions of each of the CSS files that we were dealing with. So we had a default CSS file, which was d.css. We had an admin CSS file, and then we had our advanced CSS file, which was a.css. So just to kind of talk about file sizes for a moment, if a browser supported Brotli compression, they would get the advanced CSS file, which was 2 kilobytes. If the browser didn't, but it supported gzip compression, it would get a 3 kilobyte file. And everyone else would get about an 8 kilobyte file. So pretty significant size reduction if you did support Brotli compression, which most modern browsers do now. So we had a similar approach in JavaScript. We wrote modular JavaScript and grouped things as appropriate. We didn't go the ES6 route and all of that sort of stuff. We just focused on kind of traditional vanilla JavaScript. We then combined those files into, we kind of merged them together, concatenated them based on folder structure. So we used gulp folders to be able to traverse the folders, and then gulp concat to concatenate the files that were in each of those folders into a single file. So that allowed us to write a bunch of different JavaScript files and keep it very modular for ourselves without having to deal with imports and all that sort of stuff. We created a wrapping closure to isolate each of these, the code in each of these JavaScript files from other JavaScript. We used gulp insert for that. And then we, of course, minified them using uglify, and then did the gzip and Brotli compression as well. So to give an example, in terms of one file, this is our main JavaScript file. I don't know, it's probably about 12 or 13 files, about 8K all up uncompressed in the main folder. And then once the various tasks had run, we ended up with the minified version, uncompressed, being 4K, and then the gzip version being 2K, and the Brotli compressed version being 1K. And so we ran this process for each of them. Those of you who are wondering why there is a non-minified version as well, we kept that around if we needed to switch for debugging purposes to our non-minified version for any reason, if we had JavaScript errors. Just a side note, if you are using these various gulp tasks and you want some files to be loaded first, you can create a map to do that, but you can also use the file names themselves to do that. So what I ended up doing was using an underscore for modules that I wanted loaded early automatically, and then I used an omega, the Greek letter omega, as the file name, so omega.js for stuff that I wanted pulled at the end, because the way that the gulp folder tool works and most file systems work is that they automatically read a directory alphabetically. So underscore always came first, and omega was able to come last. Now, even though, as I mentioned, even though we were using a Node backend, we actually pre-compressed not only our JavaScript and our CSS files, but we pre-compressed any HTML files that we could as well, so that we had one less task for the server to do dynamically, which further reduced the processing time that was going on. And then on top of that, also to improve server performance, we used Varnish to cache dynamic pages that were being generated out of the Node backend. All right, moving on to step 4. Think about when you load assets. So we had 10 JavaScript files all up in the website. 2 of those files were global. We had 1 browser-specific file, which I'll get to in a moment. And then we had 7 that were page or feature-specific JavaScript files. Per the common wisdom, we went ahead and had our main.js file loaded at the, we put that script element just before the close of the body element. And since JavaScript was not necessary, because we, abiding by the rules of the contest, wanted the site to work without JavaScript as well, we used JavaScript as an enhancement. We were able to then use the defer attribute on our scripts in order to defer loading the JavaScript that was going to affect the home page, for instance. So the defer attribute, when placed on a script element, tells the browser to it doesn't need to worry about this particular file. It's not going to manipulate the DOM in any way that it should be concerned about. So it can go ahead and render the page and not worry about this being a blocking piece of JavaScript. So we use that to defer loading of the page-specific scripts. Now, defer is one option. Another option is async. And async means that it basically leaves it up to the browser to run the request to get that script whenever it or rather run that script whenever it becomes available, but it tells it don't delay page load. They're very similar in terms of the way that they work. One explicitly tells it to wait to the end. The other one says, do it whenever you want. It shouldn't block anything though. So knowing that these 2 attributes exist, it's tempting to say, hey, why not defer or asynchronously load every bit of JavaScript? Maybe if we put async on everything, right? But the problem there is that with async, we don't control when things are loading. So in this case, I have a main JavaScript file followed by a home JavaScript file. Now, if the home JavaScript file has a function in it that calls some sort of functionality from the main JavaScript file, if the main JavaScript file hasn't loaded yet, it's going to throw an error. This is what's called a race condition. So in order to avoid race conditions, we only used async and defer on files other than our main JavaScript file. Now, some of you may be wondering, why did we use so many files? Right? It's a fair question. So parallel connections in the world of HTTP1, which is what we've been working with for a long time, they're few and far between. So IE9 allows you to have 6 simultaneous connections at the same time. IE10 upped it to 8. IE11 upped it to lucky 13. Every other browser is at 6. And then they have caps for the total number of HTTP requests that can be running at any given time as well. So that would include CDN shards and such. So under HTTP1, we also had to deal with what's called head of line blocking, where resource requests need to be resolved before a new one could be made. So you might say, I need the main CSS, and it would need that to resolve before it could request, an SVG, and then another SVG, and then some JavaScript, and then another JavaScript, right? It would need to kind of put these in line and wait for them to come down. Now, HTTP2 is quite an advancement over that. And among its many features, it offers a single connection where the contents from the server can actually just stream in. So what that looks like is that you can request as much as you want, and it's only using that one connection. And each of those, the resolutions, the responses from the web server for each of those assets that you're requesting resolve on their own timeline. So for those of you who are familiar with kind of the waterfall in dev tools, where you would see one thing and then the next thing load and then the next thing load, that's the one TCP connection being shared across each of those resources over HTTP1. Now in HTTP2, everything can sort of have the same starting point. So you have the HTML that gets loaded, and then once that's finished and it kicks off the requests for all of the varying assets, it can do that all at the same time and all over one TCP connection. And some may take longer to resolve, but ultimately it's a lot faster. Now, Akamai put together a great demo that shows HTTP1 versus HTTP2. Now, for those of you who can't, for those of you who can't see it, I'll describe what's happening here. So on the left-hand side is an example of 379 individual tiles that make up a full image being loaded. And so being loaded over HTTP1. And so the total load time is 5.4 seconds. This is with a latency of 83 milliseconds, and it takes a while, and it kind of chunks in, right? It kind of builds up and looks a little funky. On the right-hand side, we have HTTP2 at a little bit lower latency, but not too much, 81 milliseconds. The load time is 2.16 seconds. And so it just basically fills in across the board. It's pretty impressive. So HTTP2 is definitely something you should look into if you haven't already. Now, Stephen Baumgartner wrote a great piece for List-Apart called "The Best Request is No Request Revisited." I highly recommend reading it. It kind of looks at the wisdom that's been with us since the early days of YSlow, where we were told, like, make as few requests as possible. And it says, okay, does this still hold up? Is this something that we need to be worried about in this world of HTTP2? So I recommend reading that when you come down off of the 24-hour high that you've been on here. All right, step 5, consider how you load your assets. So the way that we set up our CSS was we actually have 2 separate style sheets, you might remember, apart from the admin one, which only showed up if we were administering the site. So we had the D, or default style sheet, which is tiny. And that just handled things like colors and basic typography. It did nothing with regard to layout. And what that enabled us to do was deliver a experience to older browsers very easily, because they would be able to understand colors and typography and such. We wouldn't even bother sending them media queries and such. Then we had a second link element pointing to the advanced style sheet. And for this one, we actually attached a media query to the link element using the media attribute. And so the media attribute says only screen. And what that enabled us to do was only deliver those CSS assets to modern browsers, which is pretty cool. So we didn't even have to worry about testing IE8 and below from a CSS standpoint, because they don't understand media queries. They won't get that style sheet at all. And so they just get the default mobile first look and feel. So that's one of the cool things about kind of how fault tolerance works in CSS. Because the browser doesn't know what to do with the only keyword, then it will go ahead and ignore that style sheet entirely, and it won't download it. So we've just saved those people downloading a bunch of styles that they're not going to have any use for and that might cause problems, which is pretty cool. And I'm honestly fine giving older browsers mobile layouts. So the other thing that we did was we used sort of conditional scripting in a similar way. So conditional comments, while no longer supported in modern versions of IE and Edge, can actually still be useful. So the one that I have up here, the conditional comment syntax is a little strange. So I'm not going to walk through the brackets and the exclamation points and stuff, but it looks like a comment. And basically what happens is that any browser that is not a version of IE, which is IE10 and below, IE9 and below, because IE10 got rid of support for conditional comments, will actually just see this as a comment. But IE9 and below, we'll see it as a conditional comment and then evaluate the conditional that's inside of it. And in this case, if LT IE9 says that if we're dealing with IE and the version number is less than 9, then to go ahead and include the contents of the conditional comment, which in this case is a bit of JavaScript that delivers what's referred to as the HTML5 shim to IE8 and below so that our HTML5 elements render properly. That's a tiny bit of code that does that. So IE8 and below get the shim. Nobody else has to deal with it. Now, we actually use this in reverse as well, and this one is even weirder looking. I definitely recommend looking at the source code of the 10K apart site, which is a-k-apart.com. And so you can use conditional comments in an inverted way to actually hide specific content from older browsers. So what we did in this instance is all of the JavaScript that we were loading, which was pretty minimal to begin with, we wrapped it in one of these conditional comments so that if the browser was either didn't understand conditional comments or was greater than IE8, so it was IE9 or above, it would see our JavaScript, but IE8 and below would not. So that was a way of basically removing IE8 from our test matrix entirely and not really having to worry about what we were doing with it, which was pretty cool. And since the site works without JavaScript, we were all set to go. Now, you can also load images conditionally. And we did that in the Flitter with the Microsoft Edge and the AEA and Events Apart logos. And we did that by sequestering our image loading within a media query. So when you use mobile-first media queries, unless that media query is actually applied to the current screen, the images will not be requested. So in this case, we used generated content to inject 2 different background images onto, or before, rather, the link pointing to Microsoft or pointing to the Event Apart site. So the first one was background image of URL to the Edge PNG file. And then we had a second background image, which was pointing to the SVG version, comma, none. And the way that we did, or the reason that we did that was that browsers that support multiple background images actually also support SVG. Like the matrices actually line up perfectly there. So if the browser didn't support SVG, they'd get the ping. If they did, they get the SVG, which was pretty cool. We did a similar thing with the animation for the homepage. There's like this very cool SVG machine that Sarah Drasner built for us. And it has a very neat animation to it. And we made this because it was kind of eye candy, and it's a little bit interactive, but we didn't want to load it if there wasn't enough room for it, and if it didn't make sense, if the user wasn't going to get much benefit from it. So we referred to this as hero. So this was the hero.js file. Now, I'm going to walk you through what I refer to as an interface experience map to show how we enhance the experience for different people based on certain conditions. So we start with page load. And the first sort of condition that determines what happens is whether or not JavaScript's available. If JavaScript's available, we're not going to have any image. That's the default experience. Always defaulting in favor of performance. So the next step, if we did have JavaScript, was to verify the browser width condition. Is this page big enough that it actually makes sense to load in this SVG animation? If not, then we just leave it in the no image condition. If it is, then we go ahead and test whether SVG is supported. You may remember I mentioned that earlier. If it's not, we fall back to a picture element with different sized images in bitmap formats. But if it does, then we go ahead and make an AJAX request to load the SVG file, yank out the script information and load that into the document because the SVG is scripted as well. And then we render the SVG into the page. And there's an additional step as well where we actually save the markup. So whatever the results are of that, we save that in local storage. So the next time this page is loaded, we already know the result. We can just provide the result rather than having to go through the whole process again. So it speeds up the second view of the homepage. Step 6, only load assets when they actually add value. So images can be really useful to draw users' eyes when dealing with a page where competition is high, but they become less useful when competition is low. So we need to evaluate images on a case-by-case basis because some images are nice to have, but not necessary. So I suggest asking questions like, does the image reiterate information found in the surrounding text? If it does, it might be good to leave it out. Is the image necessary to understand the surrounding content? Does it contain text? Is the image a graph, a chart, or a table? Could the content of the image be presented in a different format that wouldn't require an image? And is the image purely presentational? Images account for about 53% of the average web page, and we really need to justify each and every one we use. And the reality is that they don't always fit. There are often instances where there's an image being injected into the page and it actually causes the layout to break and look ugly on certain screens, like the one I have up here. Which I'm not remembering which site, The Guardian, I think this was from, and this is viewed on Opera Mini, and there's an image that's pushing over the headline, which doesn't wrap around it, and so it's like really squishing it down. You have the word earthquakes breaking on the K, so the ES is on its own line, and then it's running into the comments. Yeah, it's really awful. And the truth is that not every article needs a picture. There's a great article on theoutline.com that I highly recommend reading that is called Not Every Article Needs a Picture. And it's interesting, especially because it comes from a non-tech perspective. And essentially the TLDR on this is that if you're writing an article about cybersecurity, I don't really need to see some stock photo of a phony hacker. Unless it adds real value, leave it out. So if you can avoid using an image, do it. We should justify each and every one that we use. If you do need an image, choose the best format. I'm going to run through some high-level bits about image formats, but Una Kravitz has a great talk on image formats that she gave at AA in Denver last year that goes way into more depth than I do. I'm just going to hit some treetops here. So GIFs, GIFs, however you want to say it, don't care. These are great for images with large swaths of solid color or where you need just binary transparency. JPEGs are great for photographs and images with gradations of color. They can be compressed, but that does introduce artifacts, so it makes them not look as great. 8-bit PNGs can be an great alternative to a GIF, but they can also support alpha transparency with the right creation software, which is pretty cool. 24-bit PNGs are a great alternative to JPEG, but they're usually larger, although they do support alpha transparency, so that's kind of cool too. Then there's WebP, which is a newer format. It is getting better supported. Firefox and Edge both just rolled out support for WebP, and Chrome has support for it, so it's definitely getting up there, and it's smaller than JPEGs and 24-bit PNGs. It supports alpha transparency and a bunch of other things too. Now, sometimes there are images that are legitimately nice to have. They're not required, but they're kind of cool. So in the case of the 10K Apart site, we had the images of our judges that we thought we'd like to show their nice smiling faces. But that's 29K of images that we would be loading in there. So our default experience is not to have them. So we just show their names. Now, the way that we set it up, I'm actually gonna walk you through here. So each person was a list item and had a data attribute on it. And that data attribute was data-image, and then it had a path to the image and some other stuff, which I'll get into in a moment. But the default was not to have images in there at all. It was just a link to the person and their name, right? So I wrote up a little shorthand that enabled me to define how the image should be loaded. It started with the image path, and then there was a vertical pipe, and then in there I could put alt text if I wanted to. In this case, since I've got the person's name right after where the image is going to be generated anyway, there wasn't any value in adding text to the alt attribute, although the alt attribute will be generated into the image. And then the last bit was whether it was going to prepend or append to the element that it is. In this case, it's going to prepend it because I've got a Y in there. It was a Y or N. Don't worry about understanding the JavaScript that I've got up here, but I'm just going to really quickly kind of walk through what it does. The first step was to get CSS and JavaScript in sync. So the code that I have up here creates a div, which I've identified as a media query watcher, basically. And so I add an ID to it called getActiveMQ-watcher. I set its display to none, and I append it to the body. And then I, in my CSS, have a bunch of style rules that are specifically targeting the that ID'd element. So getActiveMQ-watcher, and then they have a font family applied to them. So, and each of those font families has a keyword that I'm going to pull out on the JavaScript end. And those keywords are my different media query sizes. So global was for every size, tiny, small, medium, large, larger, full. So whatever name you want to come up with, you can do it for your own breakpoints. But this is a really cool idea that Adam Bradley came up with. And so those font families can then be accessed via JavaScript using getComputedStyle, and so then pulling out the font family information. And for those of you who can see it, this is kind of a simplification of the code, of the actual code, but you can look at the site to see how it works. And then basically when the site loads, I get the active media query. And then if the media query in this case was larger or full, I would go ahead and lazy load the images. I could have additional things in there where I check network quality and stuff like that, but this is just kind of a simple version. So what it ended up doing was converting the markup from having this data image attribute on a list item to having an image element injected into it with the path to the image that I had supplied and the empty alt attribute. And then I also added the data-image attribute to the list item, and I set that to true just so that I could trigger some CSS that was specific to this as well. Now, of course, I said to optimize everything. So let's look actually, as we get to the end here, how I got the file sizes of the images themselves as low as I did. So we had a bunch of images here. I'm going to tuck into Rachel Andrews' image. The original one we got from Rachel was about 38K, and it was a JPEG. And so this is the process that we actually walked through for each of the images. The first thing I did was remove the color information. I reduced it to black and white, which shaved about 7% off the original size. I then cropped and resized the image, reducing the file size by about 68%. I then used, I blurred everything except for her face, because as humans, our eyes are drawn to faces. So you can actually cheat compression a little bit by blurring the background and blurring a person's body and keeping their face in focus, which is kind of cool. I learned that one from Jeremy Keith. And then I used Save for Web in Photoshop and then ran Image Optim on it as well. And I was able to bring it down to 9K or about 76%. So yeah, in every case, I blurred everything but their faces. Those of you who can see it can probably hardly recognize that that's actually what we've done. And then we ended up with our JPEG, which we then also did a conversion to WebP for the browsers that supported it. And if the browser could use the WebP version, it was actually about 4K for her photo as opposed to 9K, which was a total savings of 89% over the original image. Now, because not every browser supports WebP, we went ahead and used the picture element, because in the picture element, you can supply a source and then have a fallback image. So the source that we use has a type equals image/WebP, and then it has the source set pointing to the WebP version of the image, and then the image element that's inside of the picture, which is the default, has the JPEG. So it's a way of allowing the browser to decide which one it wants to use, but always trying to have the best one possible, which is kind of cool. So the first choice is going to be the WebP if it's supported, but fall back to the JPEG if it's not. It's worth noting that you can add as many sources as you want. You just put the smallest one in first, and then the first match will always win. So instead of lazy loading an image element into the list item, we lazy loaded a picture element into the list item. So again, trying to optimize absolutely every step of the way. So to summarize what I just covered, the steps that I recommend for better performance is to use native features whenever possible. Only include assets that you actually need. Optimize absolutely everything that you can. Think about when you load assets as well as how you load assets, and then only load assets when they actually add value. It's important to recognize that every choice we make affects our users' experiences. We need to be realistic about what we actually need. We need to think about what we load and how we load it. We need to make every resource fight for its place on our sites. And we need to realize that there are real trade-offs between design and performance. But regardless, we should always aim to make decisions in our users' favor over our own desires and over our own convenience. We should spend our time to save it for our users. After all, speedy performance increases the accessibility for everyone. Thank you all so much for your time and for your attention in this very, very long day. And now I'm happy to take questions if we have some.
Hey, Aaron, thank you very much. I think you've packed so much into an hour that we actually don't have any questions. I think you probably answered everything everyone had to say.
Awesome.
That really was great. Like I say, absolutely packed with good information, and I'm sure there's a lot that all of us can learn from it. So thank you very much for doing this.
Yeah, thank you for having me.
Well, we had you start the show last year, and it seems fitting to have you end this year. So thanks for coming back.
My pleasure.
Okay, so just a last call out to our sponsors. That Inclusive Design 24 was brought to you in partnership with Barclays Access, the Bassiella Group, Intopia, Microsoft Edge, and Open Access Technologies, and with thanks to our sponsors DQ Systems. If you have enjoyed ID24, please subscribe to our YouTube channel at Inclusive Design 24, and to follow our Twitter account ID24Conf. We are going to go straight from this to our after party session, where a few of us who've been hosting during the day are going to talk a little bit about what we've learned and our highlights of the day. So please join us for that. Once again, thank you, Aaron. That was absolutely fantastic way to end ID24.
All right. Thank you all, and congratulations on the event. It's awesome. Thank you for doing it.